All right, Mr. Ahmed here, section 1.4, intermediate algebra. Essential question for today is how do I solve an absolute value equation? So brief little review. Absolute value is when we see two bars around something. The bars go straight up and down. And for example, the first one, it says what is the absolute value of 2? The absolute value of 2 is 2. You might remember someone saying absolute value is always positive. So the absolute value of negative 2 is also 2. So what does absolute value actually mean? Absolute value means the distance from 0 on the number line. So if I were to plot negative 2 on the number line, that's 2 units away from 0. And 2 is also 2 units away from 0. So they're equidistant from 0 on the number line, both 2 and negative 2. Keep in mind, distance in math is always positive. If I walk backwards 10 feet, I still walked 10 feet. If I walk forwards 10 feet, I still walk 10 feet. So when we solve an absolute value equation, there's going to be, at times, more than one solution. So the first one says, solve for x. It says the absolute value of x is equal to 5. So we're going to do this in our heads. We have to say, what values make this true? So if I were to put something in for x, what's one thing that will work? Well, 5. The absolute value of 5 is also 5. So x could equal 5, and x could also equal negative 5, because the absolute value of negative 5 is also 5. Here, absolute value of x equals negative 5. What can I put in to the absolute value that's negative? Well, we just kind of said the absolute value is always positive. So if I take the absolute value of 5, it's 5. The absolute value of negative 5 is also 5. So here there is no solution. The absolute value can't equal a negative. And I could have said negative value. I just kept it short and said it can't equal a negative. So the steps to solve an absolute value equation. First, we have to isolate the absolute value on one side. So the absolute value needs to be by itself. We just want the bars and whatever inside them. Then we're going to write two related linear equations. There's both the positive case and the negative case. We will solve each equation, and then we can always check our solutions to make sure we are correct. I'm not going to expect that you check your answer every single time. So, first step, isolate the absolute value. In this case, the absolute value is right here. It's 3x plus 1. We have to get that part by itself. In order to do so, first I need to move the negative 6. To use our inverse operations, we're first going to add 6 to both sides. Then I have the absolute value, 3x plus 1. Make sure it's obvious that the 1 and the absolute value are different. That could look like an 11. And that's equal to 8 plus 6, 14. Now I write both cases. This value could equal 14, and it could also equal negative 14, because if I get negative 14 in here, the absolute value of negative 14 is 14. So I have to set up two different problems. So the first problem, 3x plus 1, could equal 14, and 3x plus 1, what's inside the absolute value, could also equal the negative case, negative 14. Now we just solve both equations. Now when I do this, I'm going to get some different values. Excuse me. You can't just subtract 1, then divide 3. Because when I subtract 1, 14 minus 1 is 13. So 3x equals 13, and subtract 1, 3x equals negative 15. Sorry. Next step, divide both sides by 3. So x could equal 13 over 3, and divide 3, x could also equal negative 5. So we found our two solutions. One common error that I'll see is we'll write out this first equation, and then someone will just say that our solution is 13 over 3 and negative 13 over 3. That's not the case, because when this is negative, it's going to change the equation a little bit. So, number 4, next example. First step, isolate the absolute value. Just like when we're solving equations, add and subtract before we multiply and divide. So first I'm going to move the positive 9 by subtracting 9 from both sides. 4 times absolute value x plus 2 equals 3 minus 9. Negative 6. Divide both sides by 4. And I get the absolute value of x plus 2 equals negative 3 over 2. So now the absolute value is isolated. Since the absolute value is equal to a negative, what's that tell us? Can this ever equal a negative number? No, there is no solution. The absolute value cannot equal a negative. All right. A couple more examples here. First one says y plus 3 equals 7. The absolute value is isolated, so I'm going to write out my two cases right away. First case, y plus 3, what's inside the absolute value? Absolute value signs are gone, equals 7, and y plus 3 also could equal negative 7. Now we have our two cases, solve both of them. Notice, when I subtract 3, I get y to equal 4. And when I subtract 3 here, it's not negative 4. Negative 7 minus 3 is negative 10. We found both solutions. Next problem. First step, isolate the absolute value. So, need to subtract 1, subtract 1. Absolute value, y plus 3 is equal to 7. And this looks very similar to the other equation. That's because it is. Set up both cases. Y plus 3 equals 7, and y plus 3 could also equal negative 7. Both the positive case and the negative case are now set up. Solve both equations. Minus 3, y is equal to 4. And minus 3, y is equal to negative 10. So case 1, case 2. All right, one more example. This one's a little bit tougher. Add and subtract before we multiply and divide. Isolate the absolute value. Going to add 5 first. Negative 2 plus 5 is 3. So I have 3 times absolute value 2x minus 3 is equal to 3. Now divide. 3's cancel. Absolute value 2x minus 3. So that's what's inside. That is equal to 3 over 3, which is 1. Set up both cases. Take what's inside the absolute value. 2x minus 3 is inside it. That could equal 1. And 2x minus 3 could also equal negative 1. Do not be lazy. Write both steps down. It's super easy to make a mistake when you start trying to solve it just from here by adding 3 and then dividing. Doesn't work. So add 3, 2x equals 4. Divide 2, and x is equal to 2. Found the first one. Steps are the same for the next part. Add 3. Notice we don't get 4. 2x equals negative 1 plus 3 is 2. Divide 2, and x is equal to 1. So we found both solutions. Now the U-tries are there. Go ahead and pause the video. Give both of them a shot, and then we will reconvene to see how you did. All right, hopefully after your pause and trying, things went okay. But number 8, pretty easy. Absolute value can't equal a negative. No solution. Next one, a little bit tougher. Slide this over, make sure we have plenty of space. First step, isolate the absolute value, add 12. Both sides, 3 times absolute value of x plus 2 is equal to 15. Then divide by 3. And absolute value x plus 2 is equal to, make that a little bigger, 5. After the absolute value is isolated, set up both cases. Case 1, x plus 2 equals 5. And our second case, x plus 2 could also equal negative 5. So it got a little bit small there on that. Hopefully everyone's able to see. Solve both. Minus 2, x equals 3. Minus 2, and x is also equal to negative 7. We found both solutions, and that is all. Make sure you write a little summary here, a couple things in your summary. You should be talking about what absolute value is. When you set up an absolute value equation, you have to solve for both the positive case and the negative case, things like that. Have a great rest of the day.